Well, Justin, we did a podcast 2 weeks ago on P&IDs.
Yeah, I saw that.
As basic as that is, and the logical thought process, I mean, we do sometimes on a conference that we went to, sometimes on another topic we're interested in. So kind of a logical progression, if we've talked about P&IDs, is to talk a little bit about 3D modeling.
Sure.
And I thought, well, I've got a great candidate who would be interested in spends all day working in that space and might be open to sharing some thoughts on that. So that's why we invited you here to talk today.
Well, thanks. I think.
Yeah, absolutely. Well, and so you run a small business here in Houston that we can chat about a little bit later in the discussion, but that's Spectrum Solutions?
Correct.
Okay. And what do you guys specialize in?
So it's mainly file-based CAD systems.
Okay.
So we focus on the piping side. So we kind of have three prongs to the business, but the major piece is the CAD administration. So it's kind of a CAD administration as an outsourced service, right? So anybody who's worked at an engineering firm knows that there's usually a guy or a group of individuals that are the CAD administration department, which set up the projects, maintain the configurations within the software, build the specifications, and all the pieces that kind of go along with that.
Yeah, and full disclosure, we worked together
Right.
at Mustang Engineering at the time, and we're in the same group, and different responsibilities, but in the same group. So, and ironically enough, when we went to start, you had, I think, left the company maybe just before, or
Yeah.
I don't remember the timing, but I didn't know what you were doing,
Yeah.
and I don't think you knew what we were doing.
Yeah, I think
And
we
then-
crossed about the same time.
Okay.
Right? It wasn't terribly far apart.
Okay, yeah.
Yeah.
Which was ironic. I probably wouldn't believe that if I didn't know that it was true. So
Right.
you guys had to be talking about that. Okay, so the topic of 3D modeling. It's been an important part of project execution for a long time. It is now also becoming an important part of operations in a lot of the scenarios we're working with from a digital twin perspective. There's a whole lot of avenues with it regarding laser scanning, reality capture, things of that nature in the operations space. But let's look at the projects for a little bit. In terms of the modeling platforms, like the history of modeling, I guess, because you'd mentioned file-based, CAD-based modeling.
Right.
And then there's also a few software packages, like in the Hexagon Aviva space, that are more of it's a little bit bigger database behind it, and it's a 3D model. It looks and feels the same, just a little different flavor there. Like, what's is it just kind of like two general like types of modeling that you've seen, or like what does that look like?
Well, I'd describe the different flavors, as you say, database driven versus file based. So in the file based, you can do database connections and connectivity as well, but it's all based in individual files such as AutoCAD files. So AutoCAD's pretty big household name. Everybody kind of knows what that is. So in the Aviva or the Hexagon database-centric programs, you don't have the individual files that consist of the models. You have the overall database. So everybody's using the tool and reading out of that database, which then gives you like a graphic representation. Right?
Yeah, I did some work with PDS in the past, and that was Oracle-based. That was the Hexagon's precursor to Smart 3D. Oracle-based, MicroStation-based, I think generally.
I would call that a file-based tool because you're using the MicroStation file.
Yes.
Right.
Yeah, like you couldn't tell. Being a reporting guy, I wanted to go grab everything I could to help the project, and I got into PDS, and I was like, hey, half of this stuff is not here.
Right.
And then the administrator was like, yeah, no big deal. That's in the files, the MicroStation files. I was like, okay, well, that presents a challenge for me. I can't report everything that I would want to get out of this because of that dependency on the files. Not that it was an incapable modeling platform, like it was a prominent modeling platform for a long time, but it was interesting how those things depended on each other. So that was actually one where you had one of the bigger database systems, but also being file dependent. in the
Right.
case.
So there's pros and cons, right? So I would say in the two major platforms that we're supporting and doing administration for, it's going to be AutoCAD Plant 3D and then CADWorks, which is a Hexagon product today.
What's the difference? So in that realm, are there other vendors that are kind of close in that realm too, or are those two?
Those are really the two.
Okay.
When it comes to what we're familiar with in an oil and gas industry, there are other applications that can be used for more manufacturing type of stuff. You got Inventor, which is an Autodesk platform. You've got SolidWorks, which is a similar type of tool to Inventor in regards to manufacturing. The differences in those tools is they're not spec driven. So when you're doing your piping specifically, because again, in our industry, the piping is kind of the biggest component.
I think of those as kind of like parts,
They are.
oftentimes, like for fabrication of a part, or in a shop or machine.
Correct. But
scenario.
you'll see those are also used for skid manufacturers.
Okay.
Okay. So if you're not really doing isometric deliverables, you'll see that those programs are sometimes used.
Yeah, because we're talking primarily. We kind of describe this generally as the energy business, right? Everything from refineries, chemical plants, LNG, nuclear, all that kind of. That's where a lot of our subject matter is. And in those cases, you're really talking about modeling the facility.
Right.
Right? The one equipment to the next, the piping interconnections, you want to generate the piping isometric so that you can fabricate that and you can ship it and you can install it. And so it's not 3D modeling of like this microphone stand or this widget or something, right? But it's 3D modeling almost more like mapping.
For sure.
You know what
So
I mean?
I always kind of described it as, CADWorks, AutoCAD Plant 3D, Aviva, those tools, the tools that we're familiar with. It's more building out the airport. SolidWorks or Inventor would be building the airplane.
Fair. I
Right.
like that. Okay, good.
So that's kind of the way I always described it. So you'll have vessel manufacturers, tank manufacturers that also do various skids for various things. An Inventor or SolidWorks would be a tool that they could use to do that because they're not needing to produce isometrics per se. And most of that stuff's done in-house.
Yeah.
So you'll see those tools used for those types of applications.
And just in case, because our listener base, we're expecting it to grow exponentially. And when people come back to refer to these, I'm expecting people from outside of our normal circles. So from a skid perspective, we're generally talking about something maybe the size of a bedroom oftentimes. Well, could be a little bit bigger, but it's a packaged equipment.
Tractor trailer,
Yeah.
something go on a 18-wheeler.
Yeah, so it can be built in a shop somewhere, put on on a trailer, driven to site, and just plumped right into place and
Sure.
plumbed up right, and then it's ready to operate. So
Right. Now, we'll see those same things in our industry as well. You'll see the modular facilities. That's actually becoming popular in the new data center development. We can get into that more as we get deeper in. But modular facilities it's a common thing.
well, yeah, in the hierarchy, you've got skids. They're often actually assembled into modules, and then those modules, like an offshore facility, might have 3 clear modules, and they're going to get stacked
Sure.
when they go offshore. So skids can, a handful of skids can fit onto a module. Those guys will then, the module might be manufactured in 2 different spots. They'll be brought together and stacked on top of each other. So the 3D model is the thing that makes that fit work, right? Within the tolerances of whatever you can deal with, and so that you can manufacture in these remote locations and bring them together. The other part of that, I guess, is the term that I most generally use is like the stick-built piece. That's what fits everything together. That means built on site, I guess, right? Like assembled there.
Yeah.
Okay, so now also industry-wise, we've got the idea of upstream, meaning production, downstream, processing, midstream, pipelines. So for example, a lot of the work that I'd done upstream, offshore platforms, and really more like offshore. Offshore seemed to be Aviva centric in the business that in my history, and then the downstream facilities were often the hexagon tool like the PDS and then the Smart 3D. Some of those, there's some crossover there. But I saw like in midstream a lot of where we're talking about the CAD works and the auto plant type stuff. So like, where do you see like either in the areas of the industry or the scale of the projects?
Yeah, so my experience for the tools that we support and what I've had experience with, most of it's midstream and downstream. I wouldn't necessarily recommend some of the tools that we use in the offshore. A lot of it has to do with the weight calcs and that type of stuff, but it's generally not used in the offshore space. But midstream and then downstream for sure. Again, I think it has to do with the flexibility and the ease of use of the tools for the project sizes. So most of our clients, most of the projects we support are going to be small cap, mid cap size projects. It's not to say that the tools can't do large projects. We've seen it, we've done it, been successful with it with 8,000, 11,000 count ISO projects. It can be done, but it's typically not the tool of choice generally when you get into those large projects. And there's a myriad of reasons for that. But outside of the upstream work, I see no reason why the file-based programs can't do small to large projects. It's the same workflow. It's just how you structure it.
Okay. Yeah, that's one of the questions about there's a bit of a cost element, I guess.
For sure.
Is that right? So those database model tools are a little bit higher on the licensing cost and the implementation cost. Is that right?
Little's relative. But yeah, so you have the cost of the tool itself.
Okay.
The infrastructure to run the tool makes a big difference. And then, of course, the administration aspect of the tool can drive your cost of your project considerably.
Okay, because when you say infrastructure, meaning if I want to do an AutoCAD-based 3D modeling plan, really I need a storage location and I need the modeling tools. Don't need any database licensing. It's just a more simple configuration.
Generally speaking, so the Autodesk stuff has come a long way. So they have their own cloud-based environment for collaboration. So they call it BIM Collaborate. Tomorrow they'll probably call it something different. They're always changing the name of the tools, but it's become pretty common. We've seen it a lot and seen it kind of grow over the last couple of years for collaboration aspects, which it's been pretty successful. So you can collaborate with other aspects or other departments or divisions or other contractors within the environment. It's all cloud-based.
That's generally one of the big drivers for the cloud-based or data-centric solutions is the work-sharing capability. Right. The ability to have multiple office locations, multiple contractor teams participating in one secure workspace. So you're seeing that grow in terms of capabilities,
capabilities and use by our clients. I mean, we have one client they're a small outfit, but they put everything in the collaboration tool, even if they're not, just because it's an easy way to manage their projects. So there's value in it, even if you're not doing large projects or legitimately collaborating with others. But if you have multiple offices in multiple different locations, it's a simple way to work share the projects.
Okay. Yeah, I had a job in the past where we were evaluating, a company had CAD works, and they were trying to understand if that was their long-term plan for realizing their 3D vision for a digital twin. And what we found there in the way that they were executing is that they have an existing refinery. They would laser scan the section that they needed to do work. They would use CADWorks to flange up to that laser scan essentially and do a small project. Then they would just archive that and it was done. They generated what they needed at the moment, and they saved it as a project, and that was it. It didn't fit into a bigger, so you could see pockets of the plant that had been scanned and modeled and done work, and it really wasn't coming together, like building toward a larger model management platform. It was localized, right? And that's a bit contradictory to this idea of having a 3D model to serve as the canvas for your digital twin.
Sure. So in their case, were they having outside firms doing the various projects, or were they doing it internally?
Yeah, I think they were having firms do that.
So I think that's where the trick is everybody kind of has to do it the same. Otherwise, stitching it together, it can be difficult, right? So provide the proper workflow and the configurations and the processes. So company A produces something and company B produces something, and you're able to stitch them together, and it makes sense. I think there's some work on the front end to make sure that can happen, to be able to do that. So I could see where there would be some struggles to be able to accomplish a comprehensive overall model that could be used as a digital twin.
Yeah, and I just wasn't sure there if part of the challenge was the technology and the way those softwares were designed to be used, and whether or not that made sense for managing a facility of that size with the strategy they were needing, or if it was it's also just a legacy workflow.
Sure.
I mean, it's not, it's a workflow that is perfectly acceptable for accomplishing the project that you need. It just didn't necessarily have some long-standing growth pattern into anything bigger than
right. And that's probably where the hang up is. It's not so much that the end result isn't good. It's just that it doesn't necessarily jive with something else.
Yeah. Now, are you guys getting much into brownfield? Like, where's your split, greenfield versus brownfield work?
In regards to like the amount of the different,
the way your company is helping the industry, where's the? Because the reason I ask is because when you're doing greenfield, it's a new project. So, and that doesn't necessarily mean a brand new facility, right? It could just be a new section of a facility, but essentially it's a new clean project. Therefore, they're obviously going to have a model. They're obviously going to have most of the latest and greatest tools. Whereas when you're working on MOCs or as-builts to a facility, there you're somewhat limited by what's available to you.
I think it's a pretty 50-50 split. Our client base is rather diverse. We've got, your traditional oil and gas energies type clients that we're familiar with, all the way to guys that are doing fisheries, pharmaceutical, mining operations. We've got some distillery type work, steel mills. And then most recently, we've been seeing the lithium battery plants, and then of course the new big thing, which is the data centers, right?
What are you 3D modeling in that data center?
The whole thing, the whole thing.
The whole thing. To what level of specificity?
So those projects are more architectural driven. So what we're seeing is the engineering firms that are really chasing that work, or the ones that seem to be the ones that are doing a lot of that currently, are your more mechanical or traditional MEP engineering firms. So they're more involved in the architectural side of things, which means they're using Revit, which is another Autodesk program. So Revit's kind of like the gold standard architectural tool.
Okay.
So they're using that, and then Plant 3D, AutoCAD Plant 3D, is coming in to do the piping side of things. And most of those projects, a lot of the piping generally is cooling water. So it's not overly complex piping like what we would be used to in a process plants environment. But Revit is not a piping tool. So it's not spec driven. It doesn't create isometrics. It's the piping per se in Revit is more plumbing type of stuff. So what you're seeing is what we would call traditional piping is using AutoCAD Plant 3D, which does work within Revit and synergize within Revit. And then again, because it's all underneath the Autodesk umbrella, you've got the BIM Collaborate tool, which has all the Revit stuff in it, and then the Plant.
What,
AutoCAD plant comes
what's
in.
the hierarchy there? Do you call that a Revit model with Plant 3D stuff running like referenced in, or do you call it a Plant 3D model with Revit? Like,
Well, I guess that depends on what department you're in. So
do
generally
they just
speaking,
bring them together and then, they do that individually and then just bring them together?
so I think most of the time when you're talking about the review aspect of it, they're using Navisworks, again, an
Okay.
Autodesk product.
That's
So-
when you get into a whole nother realm of the 3D model sphere, which is just your viewers.
Right.
And they're trying to get, like an internet browser, just trying to get easy copies, the lower license cost, easier. Some of those are even free, to where you're allowing these various packages to produce a compliant
Right.
version of the model and use for easy distribution, right?
Right. So Autodesk has done a pretty good job of packaging the tools together in collections. So when you purchase a collection of a license, it comes with a myriad of various tools. So depending on the collection you get, it'll come with the various tools. So the AEC collection, for example, you're going to get your AutoCAD, your Civil 3D, your Plant 3D. I believe Revit's in there as well, and of course Navisworks. So you kind of get the whole thing for that one price for the collection for the license. So they all work together. So you can bring your Plant 3D model into Revit and vice versa, so you can kind of see what's going on.
That is one of the things that I've noticed about the 3D modeling platforms. They seem to be pretty good at allowing the reference in from different models of different origin. Whereas, like in the P&ID realm or some of the other disciplines, the tools they're incompatible. They do what they do, and if you did them differently, then you're gonna have to make there's no real easy way to combine them. But the modeling tools, I feel like, is there some neutral format in the middle that enables all that? Like, what's the driver that's allowed that to work out?
Well, I think really it comes down to a DWG file, which is an Autodesk-based AutoCAD file. It's been around forever. So I think a lot of these tools, most of these tools, you can export to to a DWG file or some sort of Autodesk-based file, which you
Okay.
can then bring into the various viewers. Now, again, I'm talking everything underneath the Autodesk umbrella, so they've done a very good job of kind of making their tools work within each other.
But
CADWorks-
isn't that true also, though? Like, if I have a smart 3D model, it seems relatively receptive to referencing in a Navisworks model or as a reference point, not necessarily to bring in natively and work off of, but at least to refer to and visualize.
I think that's really what you're able to do is bring it in for reference purposes.
Yes.
You're not always going to be able to get a lot of the data off of it and it be as helpful as you think it's going to be, but it does give you the reference, right?
Yeah.
And you can do the same thing with Smart 3D. You could export out a file to then view, but you can't necessarily work in the native environment with the other tools. So there's some pros and cons there. So like CADWorks, for example, you can't necessarily view it in Revit in as an easy way as you would Plant 3D. I would argue that's because we were talking about different manufacturers here. Autodesk is going to want you to view their tool in their other tool.
Yeah. Now, ironically, CADWorks, which is a hexagon tool, does still work. One of its drawing file options is it the preeminent file option being AutoCAD files, and they have BricsCAD also, I guess?
Yeah, so you can run CADWorks in AutoCAD. You can also run it in BricsCAD, which is essentially a similar tool to AutoCAD. And CADWorks has its own collaboration type tool, web-based tool. I can't think of the name of it off the top of my head, but it's a BricsCAD based application. So it has its comparable. We haven't really had a whole lot of interactions with it to this point. And a lot of times the projects are driving the tools, right? So when you have you have an opportunity to bid on a job. We'll use a data center as an example, and you're bidding on your piece, which in most of the cases when we're talking about it, it's the piping. You're bidding on it, and they've kind of laid out this is what the other pieces are going to be using. Generally, that's going to be Revit. So it just naturally makes sense that Plant 3D kind of becomes that tool. Now, that being said, I have seen and heard recently where there are some companies that have been using Revit for what I would call the traditional piping. I haven't researched it a whole lot. It's interesting, but Revit's not a spec-driven tool when it comes to piping. So the way they're going about it is kind of a roundabout way to accomplish it, but it's interesting. Something kind of new.
So when you say spec driven, you've got piping specs that are, for a certain application, carbon steel, certain pressure rating. That's a type of pipe. You get a different. So you're speaking mostly about those specs,
correct?
And the fact that everything I'm going to model has to come out of this catalog that's basically been pre-built for me, and I pick the right pieces to fit in with the right spec. When something's not spec driven, what is just geometry driven?
I think at that point you just kind of have a database full of fittings, and I can go in there and create those fittings, but they're not really categorized from a spec standpoint. So, and again, I'm kind of speaking outside my knowledge base on it because I've only seen it a little bit here recently, but I've seen where in Revit folks are kind of creating a spec, but it's kind of in a roundabout way. It's not necessarily the tool was intended to do it that way, but they've kind of customized things to make it happen. So is it efficient to do it that way? I couldn't tell you. I haven't dug into it deep enough, but it's interesting that they're kind of moving that way, and it's not Autodesk that's moving that way. It's engineering firms using it.
I know as we go from one job to the next, there's always a lot of talk about, hey, the specs are in paper. We need to convert them into a form that works in the model. Just that is certainly a big element. I guess it's attractive if you say you can maybe simplify some of that or take some of that out of the mix.
Yeah, I don't know how much they're actually simplifying it versus just making it fit within the tool that they want to use. Again, I can't really speak to its success or its efficiency. Just that I saw that it had been done, and it was interesting. So we'll see if that kind of becomes something or if it's just kind of a flash in the pan. But I think what's caused that is these mechanical engineering firms, MEP type engineering firms, getting into more of something that we're familiar with and using the tool that they have and kind of fitting it into it.
Yeah. Okay. What are you seeing on the 3D models from the life cycle perspective, the use beyond the initial project?
So I think it really depends on your job and what it is that you're doing. In some cases, it makes sense. I think as an owner-operator, having a model that kind of has a life cycle to it that you're kind of maintaining makes perfect sense. I think if you're doing something like a well pad, for example, it's got a lifespan on it of 5 years, 6 years, whatever it is. Doing it for something like that, I don't think the juice is worth the squeeze.
Use it for construction,
right?
Archive the files, and you probably don't need it.
Correct.
Okay. Yeah, that's been a big topic. I mean, for me, 3D modeling. You mentioned earlier a little bit about the cost. Generally, in the scheme of project engineering tools, the 3D modeling tools are on the more expensive side. The administration is a little heavier. Even the designers who use the tool are there's cost involved there, and so what we've seen is sort of you have to have that for constructability, right? Because that's what makes the parts fit together. But then even on maybe a major new facility, the idea of then if I have that model and I'm going to maintain it for the long term, keeping up with the administration and the licensing is not a no-brainer. Also, I guess there's the fact that what you actually build may not, by the time you put it into place, it may not match the exact design quite to the to the precision that you had hoped. It still worked, and then the question is, okay, what's better? Do I take that designed model and try to fit it into the reality of what was built, or do I go with the laser scanning sort of capture when I need to come back to that in the future? So I don't know. Any thoughts on that?
So I do see pros and cons of going both ways. I think in a lot of ways, the laser scanning has become more cost effective, and I feel like just off the cuff, I would say that the laser scanning seems to be something that can be done and maintained at a more efficient cost. Now, it depends on what all you're wanting to keep up with it. If you're wanting to tag things in it, so that valve is this particular piece and this is that, so you can know where it is in the plant and be able to click on it within the environment to be able to pull that data.
Mm-hmm.
It may be something, there may be a hybrid aspect to it, or you may want the model itself. But like you said, when it comes to the modeling, and unless it's truly as built, you're never going to be exact, right? Because when we're building out the specifications and whatnot, I mean, the fittings and everything are standard dimensions. The flanged valves generally are standard dimensions, but you're always going to have items that are not, and you don't know what vendor's being used, so you're putting in something as kind of like an example, but what they end up putting in the field may be something different.
Okay. Yeah, and then, I mean, the tricky part then when you're trying to do it from a scanning capacity is there's you're going to get some generalities in that too. It's harder to tell from all the paint that's applied and the obstructions that are in the way, and to get to the precision of, okay, where's the flange, where's the valve, where's all of those parts and pieces. I think we are seeing a push toward a tagged digital twin model that could be used for procedures. It could be used for training. It could be used for planning, or even logistics of workforce and work orders and all of that stuff. But generally in that, you still want both. Sometimes you want to see that realistic viewpoint of what you're looking at, and sometimes you want to see the data-rich environment. I've even seen some scenarios where we're seeing those two meshed together, with a little slider bar. And
For sure.
Do I want to see more of the drafted model, or do I want to see more of the reality picture photogrammetry type model? I'm just seeing that evolve, but there's still a fundamental question about maintaining a drafted model, and is that attainable through when you look at operations costs and everything like that? Is the ROI there for maintaining that drafted model, even if it's perfect?
Right.
But and also you get to things like, okay, well, I'm going to have a markup on a PNID. Well, the PNID markup is relatively simple to understand. It's going to go into CAD. It's going to get updated. But translating what that mark was into the model view of that, maybe not as easy, or at least it's not in the common workflow.
Well, it's an extra step, and the question is, at the end of the day, is the step worth it? What was the purpose? And if you're talking about maintaining a digital twin, then you have purpose. But my experience with some of our clients, that are doing various things in the facility, they're updating the PNIDs, so they always have a current PNID. They aren't necessarily updating a model, assuming they even have one. So I guess in a sense, the PNID kind of plays somewhat of their digital twin, I guess, or an as-built per se.
Well, yeah, and we talk about that a lot in the terms of, if I want to have a twin, the canvas that sits upon, like let's say I want to use it for managing my work orders. I want to use it for managing my upcoming project or turnaround or something like that. Well, I could use a canvas of a location plan. It would actually be something like my home screen for my twin. Doesn't necessarily have to be a 3D model. It could be the PNID, right? Or it could be a 3D model. I think what we're seeing is the most sophisticated version of a twin is a 3D model, because you're getting a little bit of all of those things. You have you have the process equipment, but you also have its relative location and its height and all that sort of your most informative decision making process. But we talked about this a little bit on the PNID episode, which is, if you really want, it depends on what you're looking for. There's a lot of extra information in a model that you may not need if you're trying to do some, simple tagging questions or some finding a line or something like that. Maybe the model's not the easiest place to do that. So you would end up using all three. I was just kind of curious what you're seeing. Several of our owner operators have this goal of a 3D model for everything, but attaining that goal, maintaining that goal, is one that people are still working toward.
Yeah.
Like, what's a realistic way to do that?
That's a tough one. In the owner operators we work with, just making sure the specifications are staying up to date is a monumental task in itself. So keeping up with the models is just another thing, right? So there's a lot of pieces that go to it.
One aspect to that, though, too, is in theory, just like if I have a set of PNIDs and they're up to date, I feel like any project I want to do, I can go to that set of drawings and I could start the project from there without a whole lot of reevaluation or study. If I believe those are good, they're the starting point for the project. I think there's the holy grail scenario with a 3D model where you feel it's an accurate representation of your daily plant, and in theory, any project that you need to start, you'd start right there. You wouldn't have to go get a special scan, or you wouldn't have to do any preparatory work, surveying or whatnot. You would have that. The question is economically, like, does the maintenance over time, when you need that, is it worth it? All of the in-between times where you're maintaining.
Right,
it.
and that's kind of at the end of the day, it's like, okay, you've decided that you want to do that. How much do you trust the model? Mm-hmm. And that's where it gets kind of dicey, right? Because if you hand it to me and you say, it's great. I've had a lot of people that handed me specs to input for a project that they say are great, and they're not great. Mm-hmm.
Yeah.
So I think you have that same thing, right? So there's always the trust but verify. So you're going to have to confirm that what you're given is actually good information. So how can you do that efficiently and cost effectively and still have that piece that's handed to you?
Especially when you're going to fabricate something that has to bolt directly into place.
Right.
That's what I mean. Like when I make a markup on a PNID, it doesn't have any dimensions that I have to worry about, right? I'm adding something in line. Somebody has to figure out exactly where to put it and exactly how to mount it and all that sort of stuff. But in the modeling case, you would need that digital twin model, if it's an evergreen model, to be good enough to where you can actually use it for dimensions.
Right. And that's where the scan really kind of comes in and is really helpful, because if you scanned it a week ago, I feel pretty confident about it. Mm-hmm. And you don't have to scan the whole facility. You just scan that one spot, right? That one location.
What do you think about the drone photogrammetry versus the Boston Dynamics spot the dog walking around the facility versus the backpack scanners versus the tripod scanners? Like, you got any
all just
input
different
to
flavors
share?
to me. I mean, as long as you get a good quality scan and I can see what's there, how you got it really isn't important. So I'm sure in various scenarios, each one of those has its pros and cons.
Okay. Storage is a problem with those, isn't it? File size of all of that, meshing all that data together. Because like I could see a scenario where you say, hey, look, we're gonna have this automated routine. We'll put cameras up for who cares, and we'll rescan the facility. I don't know, on some regular interval, right, without even questioning, and then we'll just update that. But I think what I've seen is there's always a bit of a trick around the file size that you're trying to store
For
and
sure.
how all that stuff merges together.
I think it's gotten better, but maybe we just need to build a new data center. So
Yeah, but do we have enough water for that?
well, I mean, you got to build the power plant to run the data center next door. So it all builds on itself, right?
Yeah. Okay. Yeah, that's a shock. That's a surprise to me, to the industry. How, the nuclear power, sort of the expansion into nuclear power, the resumed interest in that, that's not too big of a stretch. I mean, we're always looking for better ways to create and manage power, but then taking resources that were traditionally more like oil, gas, chemical, and applying them to data centers it's an odd pivot for me in sort of the industry that we're
It is
talking
interesting. It is interesting, but they're talking about these data centers. They're building the data center, and then due to the sheer need of power for the data center, they're literally wanting to build a power plant
Yeah.
to run it next door.
Yeah.
Right?
No, I get it. Well, and I saw an image a while back. It said, data is the new oil, right? So there was obviously the big, boom of oil and what that could do from an energy perspective and a material perspective. And obviously you had the history of the big oil companies being dominant companies. But now if you look at the most valuable companies in the world, they're Facebook and they're Google and they're, OpenAI or whatever. They're all these companies that don't really have a lot of physical stuff. They're managing data. So
Right.
I guess applying some of those same resources that would manage energy and putting them to managing a home for all of that data. I guess it makes sense.
We'll see. I mean, 5 years ago they were telling us they were all going to wear VR headsets and work in the cloud, right? So who knows where it ends up?
Yeah, the VR thing has died down a little bit.
Yeah.
I thought it would change the engineering design process more. I thought you'd have more like modelers working, in a virtual space and placing objects. And really, you're still talking about traditional keyboards, mouse.
Yeah, I mean,
modeling, right?
I remember visiting a client and they were testing out some VR stuff, kind of like it's essentially a Navisworks model, but you were able to walk in it in VR.
Mm-hmm.
And I thought it was kind of interesting. I don't think it ever really went anywhere. And I think at the end of the day, it's just the value add to it, to be immersed into it versus just looking on a screen. I don't think it really brought a whole lot in that particular case. So I think it's been a little harder sell. I think in theory it has a kind of a neat concept, but I don't know if it's really bringing enough to the table.
So you've got a kid, right? I don't know, multiple kids. I'm not sure.
Just one.
One kid.
Yeah.
Ever played Minecraft?
No. I'm familiar with it. She plays it. Maybe she's played it a couple times, but
because I watched my kids play Minecraft, and I thought, man, these 3D modelers, they're working too hard. My kid learned Minecraft with no training, built the whole world, made flowing water and light switches and all kinds of stuff. But I say that as a joke, but it does make me wonder, like traditionally, of all of the tool sets to learn in the engineering industry, it seems like 3D is the one that if it takes 1 week to train somebody on how to do drafting of PNIDs, it might take 3 weeks to train them in a lot of training programs, or 2. It takes more time to say, okay, you're ready to do the 3D stuff, because it does include more precision. And it's just made me wonder, with the new generations of folks coming in, with the video games being more advanced and all that sort of stuff, like, do we see a scenario where it's like faster to pick up? And also, I've seen too where, like, okay, this certain person they understand Aviva E3D modeling, or they understand Hexagon Smart 3D, or they understand CADWorks, but not really between the two. They're dedicated not only to that discipline, but to that tool.
Sure.
Right? So do you see anything changing there on...
Well, again, I think it has to do, I think the analogy that kind of popped in my head is it's a sophistication thing, right? I'll put my 12-year-old in a go-kart and let her drive around the track, but I'm not putting her in a car, right?
Mm-hmm.
So I think it's the level of sophistication in the tools, which is why it would take longer to learn it, right? PNID versus routing pipe.
Have you ever tried it? Just go get somebody who's really good at Minecraft and say,
I mean, it's worth a
here,
shot.
here, build this pipe. Let's see how this works.
But I don't want to lessen the profession by saying you got 3 weeks experience of routing pipes, so therefore you're a senior piper, to the chagrin of some pipers.
What is that education path?
Well, I think a lot of it is on the job training, to be quite honest. It's experience and knowing the certain routing. Obviously, your company's standards on how certain things are done is rather important. But it routing the lines is the easy part.
The reason I ask is because we talk a little bit here in some of our discussions about education, and I think there's kind of an assumption. Okay, you're on an engineering job. You work an engineering job on an engineering project. Therefore, I guess you have a bachelor's in chemical engineering. But the truth is, like when you say piper, you're typically, when I say instrument engineer, that is someone who typically has either an electrical engineering degree or a chemical engineering degree, and then they got hired in somewhere as an instrumentation person, and they learned a sort of discipline, and they're an engineer. You could have the same thing, electrical engineer, whatever. But then I could say instrument designer. That's a much more diverse career path choice. Some will go technical school, some will go straight into the workforce, and then eventually say, well, I like the CAD, and so there's not necessarily a prescribed education path.
Sure.
So when you say, since 3D modeling in your space is primarily like from a piper perspective, what's the typical path of a piper?
Well, there are associate programs for learning the various aspects of piping design, drafting, the various standards and methods in which you would do the design of piping.
Okay.
So you can do that. There's various, I want to say trade schools, but I'm aware of a few of the local community colleges or whatever that have programs like that. That you can do. A number of designers that I know have gone through those programs. What I find it seems to be more common is guys will go through that and they'll get a certain distance through it, and then they'll end up getting a job working for a company, and they start in the starting positions, P&ID group, and work their way up. And a lot of times these guys don't even finish the program, and they just go to the job, and then they're learning it on the job. So that seems to be the most common way most of the designers, from my experience, have really learned it. They've learned it by doing the task and working for a company, which is interesting because I think you get a broad, diverse group of designers, because the type of place that you work and the type of work that you work on really can kind of narrow in your skill set on what you do. If you work at a company and all they ever do is build skids, you could be really, really knowledgeable in skids, but as soon as you get thrown into a process plants environment, it's different. So, at that point you would have a deficiency that you'd want to try to fill in, just because it's a slightly different environment that you're doing it. I would assume the same thing's going to hold true for, offshore design versus more onshore stuff. There's just different strategies, right?
I'm just kind of curious. I've got a kid going through college. She's going to come out with an engineering degree, but still is going to have to go to a place of work and really learn what they need.
Yeah.
Because the degree's not really making you functional there. And
Right.
then for the term designer in our industry, there's a much broader path that lands you at being a designer.
Sure.
Right.
So-
There's the straight one, which is you go to a tech school and you get a certificate, and or a 2-year generally.
It's a 2-year program,
and
typically.
you're a designer. But
Right.
then there are wider paths to be able to use that.
So I'll give you an example of how I kind of got into it, and then of course shameless plug for Spectrum. So my background was more construction, project management, supervision, and then I got tired of being outside all the time. I wanted a nice cozy office job.
Okay.
So I actually went to a school to learn CAD, and just kind of fell into the piping side of things through going to that school. Now that school was essentially intended to be like a 6 to 8 week program, and all you're doing is learning the tool. Okay. Now my background before I got there, I had kind of an understanding from a construction background to understand the terminology and the pieces and those types of things. So it was relatively easy for me.